All right, 1, 2, 3. Got to give the people.
What?
Give the people what they want. Give the people what they want. They want an RE face. Alright, what's up, y'all? This one should be short and sweet. We've had a number of long videos recently, so this one is just real quick, hopefully. Alright, so go ahead and get this down in your notebooks. Key feature of exponential graphs, asymptote. We're going to talk about asymptotes today. You see them in a couple different types of graphs, but you almost always, not almost, I think you always see them in exponential graphs. So write down this equation right here. Alright, and go ahead and make a table for this equation. You're going to make it, I'm going to make it at the same time. So I know that 0 starts at 20. I know that 1, this is multiplying by 1/2, so I'm basically taking half of this. 1 goes to 10, 2 goes to 5, 3 goes to 2.5, 4 goes to 1.25, 5 goes to 0.625, and finally we'll go 6 moving to 0.3125. They have a test. Cool. Alright, they were taking a test, so I had to move locations, but now I'm here. We got the same graph right here. Maybe I don't remember if we got the 6. But notice, if this is that equation, again, you already have this in your notebook, but it's y equals 20 times 1/2 to the x, right? So it's exponential decay. This equation, notice, what is my output constantly approaching, right? Number is getting smaller and smaller and smaller and smaller. It's getting closer and closer to 0. But is it ever going to hit 0? Answer is no. I can always continue to cut this number in half. And it's going to continue to be a smaller, smaller, smaller number that's going to get closer and closer and closer and closer to 0. But it's never, ever, ever going to hit 0. That is why you have what's called an asymptote, okay? So let's look at what the graph of this looks like. So go ahead and sketch this, all right? So you're going to start your graph. You're going to call up here 20. I'm going to cut it in half, call that 10. Cut it in half, call that 5. Cut it in half, call that 2.5. Cut that in half and call it 1.25, excuse me. And cut that in half and call it 0.625. That's about as small as we can get. And then we're just going to go 1, 2, 3, 4, 5, and 6. So see what happens. This is annoying. See what happens when we actually graph it. So we got 0, 20 right here. We have 1 and 10 right here. We have 2 and 5 right here. We have 3 and 2.5 right here. We have 4 and 1.25 right here. We have 5 and 0.625. Then we have 6 and something else smaller. If we did 7, it'd be even smaller, closer to 0. If we did 8, it'd be even closer to 0, right? So it's just going to stay all the way down here, and it's always going to be closer to 0 if I had this line like this. All right, and it just keeps going. Ooh, that was bad. Keeps going, keeps getting closer to 0, but never touches 0. That means my asymptote, A-S-Y-M-P-T-O-T-E, is at where y, what is it, y equals, y equals 0. It's actually the y-axis, right? This line right here is the asymptote, okay? Because this thing will get closer and closer to that line, but it will never, ever touch that line where y is always equal to 0. That's all the asymptote is. We want to make sure that you knew that. So you'll find something that a graph approaches, but it never touches. That's what you have. So let's write the equation, the definition. It's the last thing. So, asymptote. Let me make sure you can see this. Yep, you can. Is an imaginary line. An imaginary line that a graph approaches. But can never actually touch. That is what an asymptote is. In this case, it's the line where y equals 0. That's it. It's just a small thing we needed you to know so that you're familiar with. Hope you guys have a great weekend. Oh, snap. I gotta give a shout out. Shout out to Jamie. She ain't even in the class, but you come visit me every day. Show love. I got you, Jamie.